Welcome to Maths with EJD. In this video, I'll be talking about mechanism design, still under game theory, and let's go straight to it and ask ourselves what mechanism design is. What is mechanism design? Okay, all right. So mechanism design is a branch of game theory that focuses on creating rules or systems to achieve specific objectives. It works backward from desired outcomes to determine the incentives, and rules needed to achieve them. Okay, now let's look at some core concepts of mechanism design. Core concepts, core concepts in mechanism design. So, first of all, of course, we have players. This is still under game theory for sure. So we have the players, right? As usual, they are the individuals or entities, individuals or entities who participate in the mechanism. Each with their own, each with their own preferences and private information. Then, of course, since we've made mention of the idea of private information, we can as well look at that. What is private information in this situation? Private information. So, players possess information because that'll be information backing up the mechanism, e.g., willingness to pay, like willingness on the part of other people involved to pay, willingness to pay, then even the costs, all right, that the mechanism designer may not know, that the mechanism designer may not know. Okay. Then we also have the social choice rule. Social choice rule. So here, a function that maps participants' participants' preferences to an outcome, e.g., We can have allocation, resource allocation, or winner selection. Then, of course, we have incentive compatibility. Incentive compatibility. Okay. So here the mechanism should encourage, mechanism should encourage participants to act truthfully, aligning their individual incentives, their individual incentives with the desired outcome. And of course, there is individual rationality. Individual rationality. So in classical game theory, right, we assume that everybody playing the game is rational, but that's not always true, right? So in the case of mechanism design, when we talk about individual rationality, we're talking about participation, about the fact that participation in the mechanism should be beneficial, should be beneficial, or at least neutral for every player. Then we have efficiency. Efficiency. Okay. So again, the mechanism should maximize total welfare, total welfare, or achieve the designer's specific goal. Okay, so let's look at some examples. I mean, for the most part, this is basically this more of theory. So let's look at the first example. Example one, talking about auction design. Auction design. I have a video focusing on auctions. So this is maybe another aspect to it. Auction design in the aspect of revenue maximization in an auction design, revenue maximization. So here you have people having personal interest, but they try to align their personal interest with the design that has been put in place. So imagine a scenario where a seller wants to auction a painting to maximize revenue, to maximize revenue. Bidders have bidders have private valuations. That's the place of private information that we talked about. Bidders have private valuations, but may not disclose them truthfully, or may not disclose them truthfully. Okay. So how do we solve this kind of situation, right? So here, the solution is something in this line. If we use a second price, the other time we talked about second price auction, um, talking about the video on the applications of game theory in economics. So use the second price sealed bid auction. So if we use this, what are the situations here? You have the bidders submit secret bids. Bidders submit secret bids. Okay. Then after that, the highest bidder, the highest bidder wins. The highest bidder wins, but pays the second highest bid. Pays the second highest bid. So the situation is that if you have three bidders, for instance, say you have the value submitted by bidder A is say $40. I mean, let's say $40 million, so to speak. Then you have the value by bidder B is say $70 million, and then you have bidder C is putting up $100 million, and then in fact you have bidder D who is putting up say okay, bidder D, let's say bidder D is putting up $50 million. So now you can see that the biggest bid, the highest bid is $100 million, right? But what happens is that uh from here, bidder C, bidder C wins, bidder C wins the bid, okay, but pays the second highest. So you can see the second highest is this. So if you rank it, this is number one, this is number two. So bidder C wins the bid because bidder C offered the highest bid, but bidder C ends up paying $70 million, which is the second highest bid. Second highest bid. Okay. So bidder C wins for for offering the highest bid, for offering the highest bid, for offering the highest bid. Okay. Okay. I guess let me clean all of that so I can really make it clear. So four bits, and of the four bits, the highest is from bidder C. So we can say that bidder C, bidder C with the highest bid, with the highest bid, with the highest bid, wins the auction, wins the auction, but pays $70 million, being the second highest bid, being the second highest bid. So that's the kind of thing that happens when we under the second price sealed bid auction. Okay. Now, can we do a bit of analysis of this situation generally? So some analysis on this. So imagine that we have okay, why does this actually work? Why it works? Why does this system work? So truthful bidding, truthful bidding becomes the dominant strategy, becomes the dominant strategy because there's no opportunity to change anything. So truthful bidding becomes the dominant strategy. So if this kind of game is played over and over again, so the players are forced to speak the truth. So because overbidding, overbidding risks paying more, overbidding risks paying more than the bidders true valuation if they win. So if all the bidders, overbid, whoever ends up winning may have to pay more than necessary. So true valuation, if they win, then the other situation is that underbidding, right? So in case you're underbidding, you can easily lose the auction. So underbidding risks losing the auction despite despite willingness to pay more. Despite willingness to pay more. Okay. And what is the outcome of this situation? So the outcome here is such that the auction achieves truthfulness. Truthfulness. And that is talking about incentive compatibility. Incentive compatibility. So that ensuring efficient allocation. Ensuring efficient allocation. All right. So we have a side note for revenue maximization. For revenue maximization, the seller could also set a reserve price, or use other auction types, or use other auction types like Mearson's optimal auction. Mearson's optimal auction for specific conditions. Okay, but I mean, so far in this series, we've been talking about the second second price auction. Okay, so let's take another example to see how this really looks like. Say example two. So for example two, we are looking at public goods financing, public goods financing. So maybe, financing a road project, a park, transportation and things like that. So talking about public goods financing, imagine that a city plans to build a park, but contributions from residents, needs contributions from residents. So each resident values the park differently. Each resident values the park differently and may underreport their willingness to pay. So how do we take care of this situation? Here, we can consider a solution called we can use the Clarke tax, or what is called the Vickrey-Clarke, Vickrey, Vickrey-Clarke, Vickrey-Clarke Groves mechanism, Vickrey-Clarke Groves mechanism. So that's the idea of the Clarke tax. So what does that say? First, residents declare their valuations. for the park. So something close to what we saw in the case of auction. So Vickrey Clarke gross mechanism. Residents declare their valuations for the park. Then number two, the park is built. The park is built if the sum of declared valuations, if the sum of declared valuations exceeds the cost. Okay. Then number three, we now have that individuals pay a tax equal to the external costs, their decision imposes on others. Imposes on others. Okay. So how do we analyze this situation? So first of all, you see that residents are incentivized. They are incentivized to declare their true valuation, because the tax ensures fairness. So whatever you end up putting up, whether you overprice the park or underprice it, it's going to tell in the tax you're going to pay at the end of the day. So residents are incentivized to declare their true valuation because the tax ensures fairness. Then only residents who influence, the outcome pay, thereby aligning incentives with efficient decision making. Okay, so let's look at some applications of design mechanism. So applications of mechanism design, rather. Mechanism design. Of course, we have seen some applications already, right? So let's see a few more. Let's talk about marketplaces, for instance. Marketplaces. So platforms like eBay and Google Ads use auction-based mechanisms to align buyer and seller interests. Okay. Then we have its application in policy design. Policy design. So here, allocation of public resources like carbon credits, or emission permits. So mechanism design can help in this situation. And then finally, we can talk about crowdfunding, which is a big deal these days. So we have a whole lot of crowdfunding happening, especially now with the internet. And there are even special platforms designed for such scenarios. So for crowdfunding, right, Mechanism design can actually help in designing efficient systems, efficient systems to ensure fairness and resource optimization. Okay. So that is design, that is mechanism design, as far as game theory is concerned. Of course, I think this also play, I mean, as you can see already, it is a very important part of economics. It also happens to fall under game theory. So thank you for listening. If you have not subscribed to the channel, be sure to do that right away because I still have like 6 videos, of course, or something close to that in this series. Hit the notification bell so you can always get alerted each time a new video is released. Comment, let me know how helpful these videos are, and also let me know if you want me to teach a topic or solve a problem. Then don't forget to like and share so that more people can have access to this great content. Till I come your way again, keep playing the games of life with wisdom. Bye.